So for the isolation of bean protein, here are the materials used. 1 cup of beans, and it should be soaked for 1 day or overnight. 1 molarity acetic acid, a cheesecloth, a Wattman number 1 filter paper strip, a beaker, a mortar and pestle. So for the procedure, first, you need to grind the beans finely with water using a blender. Second, express the milk through cheesecloth, discard the soluble residue. Third, add 1 molarity of acetic acid, drop by drop until precipitation is complete. Allow the mixture to stand for some time. And for the fourth step, strain again through filter paper. Squeeze the water out as much as possible. For the fifth step, dry the precipitate by pressing between filter paper. And for the sixth step, weigh and dry the precipitate. And for the seventh step, be sure to keep in a cool, dry place inside a dry and clean container if not yet used. And for the last step, set an amount as intact and hydrolyzate proteins and for qualitative color reaction. So for the isolation of myoglobin from muscle, the things you need is 1. You should prepare minced beef or a steak. Second, an ammonium sulfate crystal. Third, a cheesecloth, and then 70% buffer diluted ammonium solution with a pH level 7.5, a stirring rod, and a beaker. So here's the procedure. First, you need to place 6 grams of the minced beef and 6 ml of the 70% buffer diluted ammonium solution in a small beaker. Second, gently stir the mixture for 1 minute to release the myoglobin. Third, express the dark red extract into a new beaker using cheesecloth. And the fourth, centrifuge the extract at 13,000 xg for 5 minutes. Then 5, transfer 1.5 ml of the supernatant into another empty centrifuge tube. 6, add approximately 0.3 to 0.35 grams of ammonium sulfate crystals, ground to fine powder. Mix gently until the solid dissolves and avoid frothing. And then for the 7th step, centrifuge the sample again for at least 5 minutes. And the next, decant of palisandre is observed. Let the mixture stand in an ice bath for 30 minutes to make the precipitation complete. And then, second to the last step, filter the mixture with the use of a pre-weighed filter paper. Allow it to air dry. And then for the last step, determine the mass of the precipitate and calculate the percent yield. Store the precipitate in a vial. Set an amount as intact and hydrolyzate proteins and for qualitative color reaction. So for the isolation of gluten, we need to prepare 100 grams of wheat flour, 0.01 molarity of iodine solution, a cheesecloth, a blender, a filter paper, and a beaker, and also a mortar and pestle. So for the first procedure, we need to add 100 grams of wet flour in a beaker and add enough water to make a thick dough. For the second procedure, knead with a hand. For the third, wrap the thick dough in a cheesecloth. Place it under the stream of cold water. For the fourth step, test the washing with iodine solution until all the starch is washed out. For the fifth, dry and weigh the insoluble material left or the crude gluten. And for the sixth step, be sure to keep in a cool, dry place inside a dry and clean container if not yet used. And for the last step, set an amount as intact and hydrolyzate proteins and for qualitative color reaction.
Biarritz test. In Biarritz test, of course, we have to prepare the different protein suspensions such as the gluten, the bean protein, and the egg albumin. Also, 10% sodium hydroxide and 1% copper sulfate. So procedure, in 3 ml of each protein suspension, we add a 1 ml of 10% sodium hydroxide and mix. Then we also add a drop of 1% copper sulfate solution. So after mixing all of those, the results we observe in gluten is that there's a white precipitate. In bean protein, it's a light violet, and for egg albumin, it shows a purple color. So ninhydrin test. In ninhydrin test, the materials used are the different protein suspensions and the 1% ninhydrin solution. So in this test, we also need to use a water bath because we'll do some heating. So first, we add a 0.5 ml of 1% ninhydrin solution to each 3 ml protein solution. Then each protein solution placed in the boiling water bath for about 1 to 2 minutes. After 2 minutes, we let it cool, and results were in gluten, there's just a clear color. In bean protein, we only saw a white color, and in the egg albumin, it turns to violet color, which is the only protein solution that gives a positive result in ninhydrin test. Santoprotic test. In Santoprotic test, the materials used are the different protein solution, a concentrated nitric acid, sodium hydroxide, and a water bath. So first, we add a 1 ml concentrated nitric acid in each 3 ml protein solution, and we heat it after about 30 seconds. Then we let it cool with flowing water. After, we add a concentrated sodium hydroxide drop by drop, and results where it turns to pale yellow in gluten, and in bean protein it has yellow precipitate, and in egg albumin there's a yellow appearance and precipitate.
For the Hopkins-Cole test, first he had to add 2 ml of Hopkins-Cole reagent to 3 ml of protein suspension and then mix. Second, incline the tube and add slowly 5 ml of concentrated H2SO4 down the side of the tube so that the layers form. Third, note the color formed at the junction of the two layers. Lastly, it might be necessary to rotate the tube gently to develop the color at the interface. And the result for the Hopkins-Cole test is that it has a purple colored ring. For the Millen's test, the first procedure is you had to add 5 drops of fresh melons reagent to 3 ml suspension. Second, carefully heat the mixture to boiling for 30 seconds. Third, if too much reagent has been used, the color may disappear. Lastly, note any changes that occur. And the result for the Millen's test is that it has a red or pink precipitate. For the lead acetate test, first he had to add 1 ml of 10% NaOH to 3 ml of protein suspension. Second, heat to boiling water bath for 5 to 10 minutes and then cool. Lastly, add a few drops of 1% lead acetate solution. And the result for the lead acetate test is that it has a dark brown color or black.